Hello everyone, today we're talking about exponential functions, section 4.1 in our book. We're going to break this into two parts like we did 3.6. So this is just the first part of section 4.1. First thing I want us to do is sketch the graph of the function by making a table of values. We're only going to use the calculator here to evaluate points if necessary. I'm not actually using the calculator to graph. We're going to start pretty much every single one of our exponential functions based around 0. So I'm going to use the points -2, -1, 0, 1, and 2 for my x values pretty much every time. And if I need to expand on those by adding more one way or the other, then I will. But I like to start right there just to see what's kind of happening at the y-axis. So if I go through and plug -2 in, I get 1/25. Right? 5 raised to the -2 is going to be 1/25, which is about 0.04. If I plug a -1 in, 5 raised to the -1 gives me 1/5, which is 0.2. Plug a 0 in, anything raised to the 0 power is just 1. Plug a 1 in, obviously I get 5. Plug a 2 in, 5 squared is 25. So now I can go ahead and plot these points. So and I'm going to use a different color, that should work. At -2, my value was 0.04. So just a little bit above the x-axis. At -1, I was 0.2. So again, a little bit above the x-axis. At 0, I'm at 1. And at 1, I'm at 5 with 25 at 2. So my graph looks something like this for an exponential function. This line will never cross the x-axis, meaning our x-axis is like an asymptote, a horizontal asymptote. Another key feature is it's going through the point 0, 1. So a positive exponential function with a whole number is always going to go through 0, 1. And we can see that it's a starting low, going high type of graph. So whenever we have a function in this form, our graph should look something like this. Obviously the numbers will change, but our regular transformations apply here to exponential functions as well. So pretty easy, straightforward graph. Next one, now we have a function that we are raising to an exponential power of x, and we're negating it. I'm sorry, a fraction, we had a function. A fraction raised to an exponential power of x, and then we're negating it. So that negation, as we should know, is going to flip over the x-axis, and we'll see what that looks like. So go ahead and start off with our same 5 starting points. And when we plug -2 in, we get a -16 back. So 1/4 raised to the -2 is going to be a 16, and then you negate it, right? Because you do the exponents first, so the negative's on the outside. So you plug a -2 in for x, you get a -16 back. Plug a -1 in, you would get a 4, then we negate it, so -4. Plug a 0 in, anything raised to the 0 is 1, but we negate it, so -1. 1/4 raised to the first power is obviously just 1/4, and negate it, so -1/4. Which is 0.25, -0.25. And if we plug a 2 in, we get 1/16, so -1/16, which is -0.0625. So now I can go ahead and graph this. Again, -2, -16, so at -2, I'm at -16. At -1, I'm at -4. At 0, I'm at -1, so that just took the typical 0, 1 and reflected it because we negated our entire function. At 1, we're -0.25, so just above the x-axis. And then at 2, we are barely above the x-axis. So then this exponential function something like that. With again, we'll never cross the x-axis, but this time, since we negated our function, all of our y values are negative. It's important to note that because this was a fraction, right, it starts, if you wanted the other one, you know, you saw how the other one started low and high. So this one will do the opposite, right? So if we had reflected it, basically the fraction will reflect over the y instead of as if it was just a 4. Right? If it was a 4, we would go low and high. Since it's a fraction, you go high and low, but the negative just flipped it over. So I don't know if that's coming across very well, but we'll see more examples of that. So again, fraction, I guess if you want to say the large y values are going to be on the left-hand side of the y-axis instead of the right. So more examples hopefully will make us figure that out, and you can always graph it, see what's happening to the end behavior of each. So this end behavior, as I go to negative infinity, this goes to negative infinity. This end behavior, as I go to positive infinity, is going to go to 0. Right? Eventually, we're just approaching the x-axis 0, never crossing the x-axis. Next, let's sketch the function. So we should see here that because it's a positive whole number, right, we should start low and high. We haven't negated the function. And we've got a couple transformations like we learned before. So we have the -2 on the inside, so we should know what that does to our function. And we have a +1 on the outside. We should know what that does to our function. So after we're done, let's go through and check and make sure that the correct transformations have occurred. Again, we're going to start -2 to +2. And this is just a starting point. You may need to add a couple other points. So if you plug a -2 in, you get 2 raised to the -4, which is 1/16, and then +1 is 1 and 1/16, which is approximately 1 and 1/16. That should be 1.0625. Plug a -1 in, you get 2 raised to the -3, which is 1/8 plus 1, so approximately 1 and 1/8. Well, not approximately, is 1 and 1/8, approximately 1.125. Plug a 0 in, you get 2 raised to the -2. Well, that's 1/4 plus 1 is 1 and 1/4, so that's equal to 1.25. Plug a 1 in, 1 minus 2 is -1, 2 raised to the -1 is 1/2, plus 1 is 1.5. I'm sorry. Yes, 1.5. That gives us 1.5. And then plug a 2 in, 2 raised to the 0 is 1, plus 2 is 2. And I'm going to keep going. I'm sorry, plus 2 is 2. And I'm going to keep going just a couple more to kind of get a feel of what the graph is doing, because right now these are all clumped very close together. So I can see I'm starting to break away. So I'll add 3. 3 minus 2 is 1. 2 raised to the 2. I'm sorry, 2 raised to the 1 is 2. Plus 1 is 3. And if I plug a 4 in, 4 minus 2 is 2. So 2 raised to the 2 is 4. Plus 1 is 5. Let's go ahead and graph these points. And then we can see if our transformations hold like they have in the previous chapters. So -2, positive 1.0625. -1, 1.125. 0, 1.25. 1, 1.5. 2, 2. 3, 3. And 4, 5. So you can see that this exponential function looks like this. Okay, and what has happened here, right? So the original, if it was just f of x equals 2 to the x, right, that would go through the point 0, 1, like I said, exponential functions will, if it's just a constant raised to the power of x. So it would typically go through the point 0, 1, but just like before, our transformations, the x minus 2, since the minus 2 is included with the x, means I'm shifting right 2, and the plus 1 on the outside means I'm going up 1. So instead of 0, 1, I've shifted right 2, up 1, so now this is kind of like where it crossed the y-axis before. So as long as you know how a basic exponential graph looks, you can go ahead and graph the exponential with our transformations. This question also asks us to state the domain and range. So the domain of this graph, my x values, there's no limit to my domain, right? I'm going to be able to touch any x value that I want. So my domain is negative infinity to infinity. My range, so my range, I'm never going to drop below 1, right? So typically, I don't cross the x-axis, but here I've shifted up 1. So now instead of never crossing the x-axis, I'm never going to cross the line y equals 1. So the minimum point I'm going to get is 1, and I'm not going to touch it, right? Because I'm never actually going to touch it. That's like my horizontal asymptote. And I can go to any positive value of y greater than 1. So there's my domain and range of this exponential function. And finally, again, graph. We have a unique term e in here. You may be familiar with that when you did logs before. So we're going to get definitely more into logs in this chapter. So we have this special numerical e, and then they want us to state the domain and range, and then find the asymptote, so the horizontal asymptote there. So I'm just going to show you real quick how you could type e into your calculator so you could find these values. But again, we're going to start at the same starting point around the y-axis. So I have the answers, but I'm going to go show you how I got them real quick. So on our calculator, if we want to find e raised to any power, okay, and they've negated it here, so I'll just do negative, and then if you click second, there's an e button right here, like it's the second of the ln, and it's e raised to some power. So in this case, I'm plugging a -2 in for x. So then they've given me my e raised to the -2, and then taking the negative of that gives me negative 0.135. So then I add 2 on the outside. I add 2 on the outside, and I end up with 1.86. Then I plug a -1 in, do the same thing, 1.63, plug a 0 in. Anything raised to the 0 is 1, and so here I have a -1 plus 2, that's going to give me just a 1. Then I plug a 1 in, e raised to the 1, then take the negative, add 2, gives me -0.72, so that's 0.72. And then plug a 2 in for x, take the negative, add 2, I get -5.39. So I'll go plot my points. -2, I get 1.86. -1, I get 1.63. 0, I get 1. 1, I get -0.72, so almost 1. And then 2, I get -5.39. So 1, 2, 3, 4, 5, and then a little bit more. So my E graph looks something like that. Okay, so we can see, because I took the negative, right, I flipped it over the x-axis, and my typical E graph, so I guess just a typical E graph, is going to look very similar to just our regular old exponential graph, right? So a constant exponential graph, because basically E is just a constant. It's a constant, but it's a constant with a never-ending decimal. Okay, that's all E is. It's just a number, so don't be afraid by the number. And typically it would start low and high, just like any typical exponential function. But I flipped it over the x-axis with the negative on the outside, and then I added 2 and moved it up. So that means my I can write it right here, my domain, my x values, well, no matter what x value I plug in, I'm going to get some value back. So again, my x values are all real numbers. My range, the largest y value I can get is approaching 2, right? It's never going to touch 2, but it's approaching 2. So that's the largest I can get, and I can get any other negative value for my y's. And then my asymptote, what line am I never going to cross? I'm never going to cross the line y equals 2. So we've graphed this function. We've used our transformations again. If you just realize that e to the x is just a basic, right? A basic exponential graph, right? They've negated it, so it flipped it over, then moved it up 2. So all the same transformations apply to exponential graphs. Go ahead and try the accompanying examples in the PowerPoint, and we'll go over them tomorrow in class.